Hello and welcome to PyData Global 2021. My name is Ajit Kumar. I am very happy to be here. So I will be moderating this workshop session. So I will give a brief about Professor Lu. He is currently a senior data scientist of Best Health Institute in La Jolla. That's a non-profit medical organization. So he have nearly 25 years of experience doing data science and machine learning. So you will be happy to know that he had completed his PhD some 1998. That's like now 5 years. So we are very happy to welcome you, Dr. Lu. So now I will hand over session to you.
All right, so first thing is I'm going to show you an example of some of the visualizations I've been able to do with Dash Leaflet, and then go into some of the basics. I'm not quite sure what all your backgrounds are, as far as I don't know, but I'm kind of assuming you know how to do some Python, but you may be unfamiliar with Dash, and probably not, and maybe not that familiar with geographic data. So to start off with, while you guys are trying to get the Docker notebook up, this is a visualization. Basically, it's how I spent last Christmas. We were on a project where we were trying to provide a tool for decision makers for the vaccine rollout for COVID that was about to take place. So you got to bear in mind, COVID was raging at this time. Vaccines were not actually out yet, but logistics was going to be a big deal. So what this map does is it actually shows you possible types of sites that that could distribute vaccines. And so I'm not going to get too much into the detail of this. The notebook that says getting started has the link to the actual site if you actually want to read about this. I just kind of want to show you the interactions that we're capable of. So for instance, at this sort of national level, you can navigate by clicking on a state, and it would actually also select the menu, would filter the data based on the state. I can click another state, it would traverse over there. Another feature here is the sites are actually clustered. So when they're really close together, a different marker is used as opposed to the standard marker. So this indicates that there are four here, four different potential sites. Within each of these, there are tooltips, and let's see what else is there. You could also select focusing on a particular county. I've also added a reset button to get back to the top of the map, and let's see, Kansas is usually a good example. Also, I implemented menus that or filters here that will actually let you select the type of site. So that's kind of just to give you a flavor. And most of these things, if we, time permitting, will cover enough of the building blocks that you can probably figure out how to do something like this. All right. Okay, so again, here's the link to that visualization. It's actually embedded in iframe, so it's a little bit smaller. And I ran it locally just because it would fill my screen and I could actually control the dimensions. Okay, so a quick introduction to Dash. So Dash is actually intended to be sort of to develop data-driven web applications. It's actually produced by, or it's an open source project, but backed heavily by Plotly. And so it's very convenient for taking data and graphing it. So without getting too deep into that, I'm just going to mention the two basic things is that Dash has these components, and they're very similar to React components if anybody is on the web development side of things. If not, you don't really need to worry about it. It's basically a web object. And so Dash has two basic parts to it. You have the layouts, which very much mimic how you would lay out a web page. If you are comfortable, with HTML, then this would be very basic, but we're not going to go into any really complicated structures here because essentially this is all about the maps. And so we'll have a map component, and the layout will, in most of the cases, will just simply be map, and then maybe a button. The other big aspect of Dash is callbacks. And I don't, the way the callbacks work is each component has properties. And so properties can serve as inputs, outputs, or states. And so for instance, of a button, there's a property called n-clicks, which is the number of times it's been clicked. And that increments every time a button is clicked. And if you take it as an input, it is actually it will return that number as that variable. So that's how the callback function actually receives it. So for this workshop, I'm just going to go. Oh, I should. I'm not going to read this. I guess you guys can read it at your own leisure if you want to. But for this workshop, I'm using something called Jupyter Dash. It actually allows you to embed a Dash application inside a Jupyter notebook. So here's some of the basic imports you need just for the operation of this workshop. Turns out, I think something with Jupyter Dash actually broke with the proxy. If you're running the notebook, it's important that you use the proxy because you're only going to be exposing one port. So anyhow, so these two lines, you really don't have to worry about. This is very idiosyncratic to this particular workbook. I never quite figured out in time how to fix the need for this next cell. So it's just take it on faith. The reason those two are in separate cells for some reason is a timing thing. What this basically does is, the way this works is Dash actually runs off its own port because it's really built on top of Flask. And if you're not familiar, it's just basically a web server. So there's a port associated with that. And so what this does is it basically allows you to reuse the same port that your Jupyter is using. Otherwise, you have to open up more ports for each of these. All right, so this is a very basic app. All it is there's an input field and an output field. And basically, if I change something here, it mirrors on, it basically takes the input and throws into the output. That's all this callback does. And so this is a very simple demonstration of how this callback structure works. Again, I'm just bringing this up as an example. This is how you end up building interactions, say, between a map and your data or vice versa, but we're not going to go very deep in the examples here. The last thing I mentioned here is the way I'm doing this is the Dash server has to have a port associated with it. I'm just telling it to pick one at random. The reason for that is that way I can have multiple servers running in my notebook. So if I go back to one, it'll still be working. The alternative way to do it, and I have the example down here, is you could actually set the port. And let me see. This does the exact same thing. It's the same app, except I just handling the port a little differently. And what I can do then is this command here will actually tell it to shut down the server. So if you don't want to have a lot of these processes running, because these will all correspond to another process on your computer, you can do it this way. Okay, so that's sort of, I think that's the end of the sort of the preliminaries. I want to know, does anybody need a little more time to catch up here, or that wants to get the notebook up? I'm going to look at the chat here, so otherwise I'll move forward. Okay. Been asked for, let's get another minute. In the meantime, I'll bring up the next notebook. This is actually, well, I can talk about data sources to give you guys a little more time. A lot of times you're going to get data that's, say, is geographically oriented, but you won't have, say, the geometries to draw draw the maps. A great place to get that is the U.S. Census Bureau. There are maps for everything. Look for the word cartographic boundary files, and I have brought it up here just to show you. So you can do things like you get county maps, you can get congressional districts, all kinds of different divisions. I believe school, at least if you go with specific states, you can get school districts, different kinds of subdivisions. Yeah, school districts, legislative districts. So for whatever purpose, you can probably find almost any kind of breakdown. And the reason you need this is that you got to be able to tell the leaflet how to draw the particular regions. And in the data that the notebook or the GitHub repo, I have included the county and a state map. And since they're from the US Census Bureau, pretty much unrestricted use on those. Okay, so I'm going to go ahead and start talking a little bit about geographic data. The two formats that Dash Leaflet uses are called GeoJSON and GeoBuff. Now, GeoJSON is really, and this will also extend into what I'm going to mention about geodata frames. I hope nobody is, I mean, I hope you guys have a little familiarity with at least what Pandas data frames are. Again, we won't go into a whole lot of depth there, but a little basic knowledge would be helpful here. Okay, so really GeoJSON and geodata frames are pretty much the same as their counterparts, a JSON and a data frame. The difference is that in a GeoJSON or a geodata frame, there's a column or an attribute called geometry. Okay, so let's go ahead and load a data frame here. This is from the county data frame from the Census Bureau. I'm not even exactly sure what all of these other things, attributes are, but the key things is the name of the county. The states are encoded in something called the FIPS code, which I will talk about later. Oh, I should back up. I know this is an international conference, and I am very US centric with a lot of this data. So you would probably have to, I'm sure other countries have similar resources available, and the format, the data file format should be the same. The nice thing about the US Census Bureau for the US maps is that these zip files can actually be loaded directly into GeoPandas. Oh, and I should mention, GeoPandas is basically an extension of Pandas that understands geographic data. So, so the main thing to note is that there is this geometry column, which is something that's characteristic of all GeoPandas data frames. And what this geometry column actually is, it's from another library called Shapely. It really, and you can look up, if you want to delve deeper into this, you can. Basically, it consists of four types of objects: polygons, multi-polygons, points, and multi-points. So for the census data, and I just happen to pick this one because I know which one it is. That's San Diego County. This is where West Health Institute is. And if you actually, Matplotlib, which comes as part of Jupyter, will actually show you the shape. And this is from Alaska, I believe. Oh, what happened there? Okay. Yeah, state code 2. And this is, I just wanted to give you this. This is an example of a multi-polygon, which is basically two disjoint shapes. And most likely what this is that this is probably, these are probably islands or something. Okay. And at least for US data, I would recommend, especially for states and counties, using these FIPS codes, which it's just a way of avoiding confusion between similar names or misspellings. Every county and every state and territory, I believe, in the US has a code. And for this, it makes it a lot easier to join. And quite often geographic data is given this way. All right. There is a question about, is there a standard for sharing geodata? At this point, I'm not really familiar about share, what that means. If you're talking about like being able to, this FIPS code is one way, at least for US regions, of kind of standardizing how you represent a particular geographic region. Okay, so I think at this point, this is where we will start delving a little deeper into the notebook. So far, these have been pretty lightweight as far as anything you might want to do activity-wise. I really haven't shown you anything that, that where you really would want to necessarily play around with, but we're going to start getting into the, I guess I could take a few questions right now, and just to make sure we give everyone time to get the images running. If not, I will go ahead and just.
Yeah, so participants, if you have any question, you can ask in chat. So I will forward. Otherwise, we will continue. Like, have you set up your environment? Are you able to download the image, Docker image? So if it is like, you can just reply in chat. So we'll be knowing what is the progress. So that will help Dr. Lu to continue.
And just so you know, I do have in another monitor, I do have the chat window up. So when I do have time, I can take a glance at it. Yeah. And this is okay.
So you can put your question in chat. Thank you.
All right. So I will go ahead and move on to the, there was a question about whether it has to be GeoJSON. Other formats, I mean, the shape files, I hadn't really gotten into them in detail. The shape files that the U.S. Census Bureau doesn't, it isn't a GeoJSON. It actually, there's some formats, I don't even remember what they're called, but it just turns out that GeoPandas is equipped to parse that type. And what I would find out is that for a lot of the countries, there's a question about, or mention that a lot of countries have GIS and other shape files available. I think GeoPandas is pretty, just like Pandas is very good at reading different formats of data. I believe GeoPandas is really good about parsing out the different types of shape files. And what ends up happening is that, you'll see in my pattern here that I'll convert the geodata frames into GeoJSON. So the source I'm using from the Census Bureau is, the source I'm using for the Census Bureau is not GeoJSON. I'm actually reading it in using GeoPandas, and it figures it out. And then I'm using GeoPandas to convert it to GeoJSON. Well, I guess just to give a little more time for the image, if someone's still trying to pull the image, I did not mention what GeoBuff is. That's another format that Leaflet will use, which is actually, think of it as sort of a compressed binary form. I looked at the code, and really it is it's just a format conversion, because JSON bitwise is not it's not very efficient, right? There's a lot of first of all, you're using ASCII characters. There's a lot of delimiting characters. This compresses it, and the way Dash works is most of the data ultimately gets pushed out to your browser. So you kind of want to streamline. If you're thinking about performance, you do want to streamline what you push out. So that's the reason for bringing GeoBuff here. You probably don't want to manipulate using GeoBuff, but it's sort of like your last step before you push things out. Okay, so all right. So I'll go into Dash. Let's start talking about Dash Leaflet, and I do want to point out one thing. I have no affiliation with the open source Dash Leaflet project. I just happen to find it very useful and learn quite a lot about it. And that's why I've proposed this workshop to kind of share that knowledge. All right, well, actually, we got one question. Let me take that before I go on. Actually, it's a good question about how clean it is. And one of the issues I ran into is you'll see it at the end of one of these sections. I call it the anti-meridian problem. And that is, it's not so much that the data is incorrect. It's just that when you Leaflet does not interpret it correctly because of the way it draws the maps. This happens when you have territories that split across the 180-degree longitude line. Because on one side it's minus 179, say, and on the other side it's 179. And so it'll actually draw it on opposite ends of the map. And that actually causes problems, especially if you're trying to zoom in. And you'll see that, I think it's on probably on lesson 4, because I mentioned that in detail. I've not really had issues, at least from the Census Bureau. One thing, I'll digress again just to answer this question. One thing you'll notice here on the census data is that you have these various size files, and that actually has to do with the resolution of the geometry they're providing you. You notice that this county one on the top is at 11 megs, whereas the one on the bottom is less than 1. And that just means that all the contours are in far greater detail on the top one. So in a sense, I mean, you get to choose how accurate you want it. Okay, so with that said, let's get on to Dash Leaflet. One of the reasons I discovered Dash Leaflet is that performance-wise, for the project I had mentioned, we tried different things, but at the end of the day, we knew we'd have to just deploy this as a public tool. And so things like PyLeaflet and some others that attempt to use that did not have the performance. And that's the main reason for doing this. Plus, we have a movement here at work to move more towards using Dash as our visualization platform. All right, so I'll start this out. So I'm going to just start the notebook with the usual. All right, I mentioned before, Dash deals with components. And so the first 2 components we're going to talk about are the map and tile layer. The third one, the one that we're going to get probably hit over and over again, is the GeoJSON layer. So I'm not going to go into it here. Now I've listed out all the options that can go, all the properties, I should say, that go with this map object, and there are quite a few. I'm only going to call out a few that are kind of important, the most important ones. Style I use mostly for deciding what the dimensions of my map are. Zoom is kind of tells you sort of at what zoom level you want to initially show your map. Center shows you where it should be centered, and bounds will kind of tell you bounds is another way of kind of setting the zoom and center. And that was sort of the trick I used on my map when I wanted to use the menu to drive which county or state I picked. Okay, so the first kind of exercise, this is just very basic. The first thing is this code basically will draw a map, and I just picked a particular style. Now, it turns out if by default it centers on Denmark and at this particular zoom level. And even here, it comes with these zooming arrows, so you can kind of go in and out. And you can take a minute to play with it. You have a grabber, so you can move. And let's say if I pick a spot and I keep zooming in, this actually, the way it works is that they're different resolution tiles that you're actually getting from a tile server. So you can get actually fairly detailed when you zoom way in. All right. So this is sort of the kind of interaction, just very basic out of the box. And at this point, I haven't done anything except add I'll get into this tile layer, but if I just created a map element, it's essentially an empty container. It's very much like, for those of you familiar with HTML, it's very much like a div, an all-purpose kind of catch-all. The only thing that's different is it has a bunch of properties that are very useful, such as the zoom and the center. Those are attributable to the map. The tile layer is what draws all these pictures, which are essentially the tiles. So this is getting pretty deep somewhere in France. I honestly don't, was it France or Germany? Anyway. And so you can play with that. Now, for a lot of the visualizations I use, the US is the center. So what I will do is I will take, and this is sort of the pattern. I'm in a lot of these cases, I'm going to keep adding on to the primary example. But in order to let you know sort of how we kind of finish, in this case, there's not that much to do, but to kind of let you know how I'm going to finish up. I've created I'll have a cell here, which is not executable. It's an a raw NB convert cell, but that'll show you the final state of the code after all the playing I do, so that you'll have kind of if you reset this, you'll have my start point, my finish point, and then you can play around all you want in the middle. All right, so it just turns out after some, I think I actually took this from the Dash Leaflet documentation, but this centers the US and puts it, the continental US, and puts it at a reasonable zoom rate. Okay, so I'll give you guys a minute to play around with that. You can change, I can start out, change the zoom to 7, which will probably put me somewhere in Kansas in the middle. Yeah, and I can get even more detailed if I want to. Okay. Let me pause for a moment. Anybody have questions or difficulties with this so far? I mean, this is very basic as far as the Dash Leaflet, but I just want to make sure if you're having issues with the notebooks. Give a minute. And all right, well, you can break in before we finish the next exercise if you're having trouble or need me to slow down. Okay, so the next layer I'll talk about is the tile layer. This is the one that actually is responsible for that underlying map. By default, it uses the OpenStreetMap. Now, there's a link here included in the notebook. If you, I can bring it up actually. This actually is sort of a wiki that gives a list of a bunch of tile servers, some commercial, some free. Some of them are regional, and some of them are worldwide. So you can find your different maps here. So if you're kind of wondering where you get the find these tile servers, is one place. Theoretically, if you get really motivated, you can actually, create your own tile server. That seems like way too much work, but I have heard of people doing that, and that's part of this OpenStreetMap project. You can always contribute your tiles back to them. All right, so, oh, and I should mention as well, before I get too deep into this, I thought I had to include in the slide. It's always good to know where to try to look for answers. So there is, the leaflet documentation is actually pretty good at describing most of these properties you'll find. So like, for instance, this one will tell me for the tile layers what those properties are. So because I won't, I don't have time to go through every property, and to be honest, half of them, which I don't use, I actually don't know what they do. The other place to look for is, I thought I had it up here, but Dash Leaflet. also has their own documentation. Now, you could think of it more as a bunch of examples because it doesn't go through a lot of explanation very well. And you'll see that I lifted some of my examples off of this page. So, but those are two good places. I'll go ahead and post that one to the chat because I did not include it in the documentation. All right, so so I've included the actual explicit URL for this is actually the default. And I'll explain the little curly braces, what those mean too, because basically, I believe X and Y is, I think, fairly self-evident, the XY coordinates, but Z, I believe, is sort of the zoom level. And then S is it's the server. If you noticed on the tile server page, there's some that might, some of these will list A, B, and C. So this, let me highlight it. This one shows A, B, and C. So that's sort of a wild card, so it can randomly pick the appropriate server. You really don't need to know what that is, but only that you need to keep it in here in the URL. All right, so this map doesn't look any different than the one I gave in the first example. Let's see. One of the things, okay, so the two properties I wanted to mention about the tile layer, because for the most part, there's not a whole lot you need to customize. You pick the tile server you like, and you pick them, and you can use the URL for that. The other thing, which is kind of important in our line of work as data people, is that all data should be properly attributed. So there's this attribution property, and I'll take my attribution from here. It's an HTML, and a lot of times the map producers will actually give you. Does this not copy? Maybe. The map producers do not, will actually give you the attribution HTML. Oops. And then I would add this as a property to my. And so what does this actually do? It generates this down here in the corner. And basically, it says this map data is from OpenStreetMap, and it's the Creative Commons licensing. Now, just so that you can see something a little interesting, a little different, this is a different tile map. You'll see this is quite different. This is a topographical map. Still gets down to, like, when you get down to the street level, you'll still see, I mean, if you get down deep enough, you do get down to the street level, but it does have all the topographical features. Those are the two basic, free maps that I found. There are a few others that are sort of free or sort of in the freemium model, but that's basically it. Okay, so this is just playing with maps and has nothing to do with data so far. It just allows you to draw maps and let's see, it allows you to draw maps and it allows you to manipulate them to some degree. Okay, so I'll take a little break. I say a question came up. Someone was asking about Mapbox. Okay, well, I think, one thing is Mapbox. If you use that, that's it's sort of under a freemium model. So it turns out you have to use a license key and a few other things to, even if you're using it for free. We did try Mapbox, but for some reason for performance, it didn't work as well. Maybe we weren't using it right, but at the time, this was just before the Christmas holidays, and we wanted to try to get something out before the New Year's. And so we're just searching for solutions that work fast. This functionality actually is, there's quite a lot of this, and you'll see later on that there's no getting around pushing a lot of this functionality and using some JavaScript. And so you'll just need to know enough JavaScript to be dangerous, but to really use this. Okay. So now back to the exercise. The real bread and butter here is going to be this GeoJSON layer. It's this is where your data meshes with all this map stuff. So we've talked all about this, the maps, but you know, this wouldn't be a visualization if you're not going to represent data somehow on a map. Okay, so the key property, the most important property are these data properties. Now, data you provide as a either in this GeoJSON I mentioned or GeoBuff format, and really there's just a helper function that can convert GeoJSON to GeoBuff. And I believe in his the Dash Leaflet documentation, he actually gives a benchmark comparison, and by far GeoBuff is faster, mainly because you're pushing the actual data you're pushing from your backend server to the browser is much smaller. The other possible way of representing your data is through a URL. You could actually specify a URL so it pulls that, and as opposed to you pushing it out from your Dash server. I did notice one pattern about these properties. If it has a strange camel case, it is actually one of the native React components that is represented in Leaflet. So you would look at the Leaflet documentation. If it uses this kind of lowercase underscore, like click feature, that is something that was added for the purpose of Dash Leaflet. And so you would look in the Dash Leaflet documentation. So if you have trouble, that's one of the problems. He basically defers most of the options back to the Leaflet documentation. So unless it's one of these underscore features, you probably need to find the property in Dash Leaflet. But I'm going to go through the one, at least the properties I think are the most important. Speaking of those underscore features, these three are kind of the ones you want if you want to build interaction. So say that you want to click something on the map and you click a feature, which is either a state or a point, which might be a city, and you may want to drive some other part of your visualization. We're not going to get into that kind of elaborate stuff here, but you know, if you want to do a cross filter where you have a graph on the right side and the map on the left, and you want to use the map to drive the graph on the right, you could connect it using this click feature. And the click feature, when I mentioned the callbacks, can be used as an input, and that input will provide you with the basically the row that represents that feature in your data frame. So if it's a state, say California, it'll give you everything in California's row. Hover feature is very similar to click feature. This just has to do with when you actually hover over a feature as opposed to clicking on it. It's just what triggers the behavior. And clicks is more of a rudimentary one. I probably wouldn't use that. I just bring it up here because these are the three interaction properties in the GeoJSON layer. Zoom properties, actually, that's how you do some of the very basic navigation. Zoom to data and zoom to bound on click. Well, I'll play with the latter one here, but we'll talk more about zoom to bound in the next section. Okay, so again, I'm going to load the state data this time. And okay, so a little word about the data here. The geodata frame has a function called, has a method called JSON, which actually produces a JSON string. But you actually want for Dash Leaflet, you want to represent it as a Python dictionary. So I use the JSON library to then load this string so that this result, let me go ahead and just show you. So if you look at this data frame, you'll see that it starts and ends with a single quote. So this is actually a string. It is not a Python object. So by doing this, JSON load S, which basically loads a JSON string into a Python dictionary. Now this is a proper Python dictionary. So that's, I just kind of wanted to mention that in case, you go through this and you're on your own and you stick the data frame, you do a to JSON and you're like, why doesn't this work? And so that's an important step to remember. Okay, so this is the US. Now that shapefile I have, you can see that it has actually drawn an outline on the different states. And I will, I'll get into some of the zooming features a little more later. I figured out my problem. I have a really weird arrangement on my desk, and getting to the keyboard sometimes causes me a problem. Now I figured out how to configure it right. Zoom to bounds on click was, I believe, the property I mentioned above. If I actually add that, and feel free to do the same. Okay, it won't do anything different as far as the drawing, but now when I click on a feature, it zooms to that particular feature and centers it and picks the appropriate zoom level. So if I go over here to Rhode Island, which is small, it'll magnify it. And then if I say pick a bigger state, I'm not even sure where I am now. Looks like, okay, maybe Michigan, yeah. And that'll zoom back out so that Michigan is properly framed. So that's a very convenient feature for navigation, especially if you're going to do any kind of visualization that involves a particular region. All right, so this might be a good breaking point. Guess I don't see any new questions here. Maybe I'll give you a minute or two to just play around with that and click around a little bit. There'll be more variations in the next few lessons. I think we're actually moving along at a pretty good pace here. So let me know if I'm going too fast. I'm kind of anxious to try to get as much of this in as possible. So don't see any complaints on the chat, so I hope everything is kind of going okay. Okay. And that's a good question. Actually, one of the features about the in the demonstration I showed, one of the key reasons we had to go with that is we had 70,000, potential vaccine sites to do data about, and it was not just simply just the geographic point. We also had a lot of data surrounding each point we need to represent. So I think for the most part, what a lot of this does is, because this is actually written in React, is that it will, a lot of the mapping functionality is pushed to the browser. So the performance actually has a lot to do with who your end user is. If they're on a really old machine trying to run an old browser, it can kind of bog down. I've noticed that when we're doing the 70,000 points. And actually this is a question from Toby in the chat. In fact, I believe in the example I did show, I did exactly that. See, this is still up here. If you recall, when I start out here, actually, if I start out at the national level, and then this is actually not really zooming in. I think you could actually trigger it on the zoom level as well, but based on the click, it zoomed in and then showed county data for that particular one. You could actually do, you could say at zoom level 5, show county level, but that actually, the way you would do that is you would actually change the shape. You would push a different set of shapes out at a different zoom level. And there's actually a question on specific research. And I think that really has a lot to do with, how you want to represent things. So, I'm not so sure about the glaciers, but because that's more of this works much better when you have some kind of political boundaries. You could kind of do you could map out things like for global warming. You could have do countries by their carbon footprint per capita or something like that. You can kind of show at a glance who's the most what's the word? Well, who are the good actors and the bad actors, I suppose. But if you wanted to try to do, you can lay on top of these things, general graphics, like you want to show where, you've probably seen those maps about which regions have warmed and cooled, and that you'd have to draw your own geographic boundaries. It can be done, but that's sort of not the way. At this point, I could probably figure it out given enough time, but this is not the kind of area where I've had experience. So these work a lot better if you have well-defined geographic features that you're trying to represent. Okay, so let me go ahead and move on to the next one. This is where we start. This is probably going to be sort of the last, I think, basic capabilities, and then we'll start getting into the so stuff that might be more applicable. So this, sort of the building blocks. So I'm going to load in both the county and state data, and you'll see why later. So kind of where we left off at the end of the last lesson was this map. And I think I'd already gave you the zoom to bounds on click is true. All right, so that gives us that interaction. Let's see what the next thing. All right, so one thing you'll probably want to do is, okay, so all right, so let me back up here. First thing you probably want to do is you may want to control how this looks. Right now, it's blue, and that's sort of the default. But let's say I wanted to change that a little bit. There's two ways. There's in the options property, there's actually a element called style, and that's also a dictionary. Let's say color equals red. Now it's the boundary's red. Now you'll notice that sort of the fill is sort of a mixture of what you specify as a fill color, opacity, and so forth. So because I said it was red, it kind of became red. But let's say now I want fill color to be purple. So it's now purplish. If I actually change the opacity, fill opacity, which is to 1. Now I'm going to make it a solid color. Now it is actually that purple. A few other properties here. I can change the weight. I mean, I think this opacity of 1 is pretty ugly, so I'm going to change that. But let's say the weight, I want to make it really thin, make it 1. So now this is a thinner boundary. So this is just sort of your first step at styling. Color can be done, using our, so this is still red, but it's using that. And there's also, I think the other one was GB. Yeah, so that's a little bit more muted red. All 3 of those syntaxes are what I just call the CSS color syntax. So any of those things that you do in a CSS file. And if you're not familiar with CSS, you can, you could just simply use this RGB and then pick your RGB codes, especially if, you have some kind of styling guideline you have to adhere to. Just simply pick the colors that are given to you. The other one, which I don't have a whole lot of, I didn't use, but I put it out there, is that you can also do a dashed array. Let me copy that from my example. What this can do is it basically makes your background makes the borders dashed as opposed to solid. And again, I left the navigation in, so you can feel free to play around with this. I'll give you a minute to play around with it while I reset the next exercise. But go ahead. So these are the 5 properties you can play with. I did not do anything with the border opacity. You might want to do that. If you want the lines to be a little lighter. Okay, so this is all, I guess this comes to lecture time. Now, problem is that Leaflet is a JavaScript, and more specifically a React library. So if you really want to get into some of the really detailed customizations, you're going to have to do some JavaScript. JavaScript is presented, it can be introduced in 3 ways. And there's a library called Dash Extensions. And if you were building this, and not using the notebook, you may have to pip install this as well. It's put out by the same guy who did the Dash Leaflet. So I think these kind of go hand in hand. And I don't really know that much about JavaScript. So I'm just going to give you my take on my understanding. The arrow function is basically, let's say that you need to pass a function, but the function is going to return the same thing all the time. That's what the arrow function does. And I think it gets its name because that's the way one way of representing it in JavaScript. But basically, you take, in the case you'll see below, you're going to take a dictionary and you want to return that all the time. So you want your function to return the same fixed dictionary every time. Another way is to do this assign function, which is actually a way of inlining a JavaScript string. And the final way is that you can specify a namespace. And I'll get into this a little bit more because that's actually my preferred way of using it. But so anyway, namespace is a way of actually referencing a JavaScript library that you've loaded. Okay, so why is this important, especially at this point? One of the properties I believe I listed up here, that I mentioned up here anyway, is this, did I mention it? Oh, it's because I had undone my markdown. Yeah, hover style is another property. that, okay, I actually misspelled it up there, that actually requires a JavaScript function. So in this case, I'm specifying hover style and I'm passing it this function, but it's going to only return this dictionary every time, which sets weight to 6. Okay, so this is identical to the previous example, except I've now added this hover style. So now when I hover over a space, you can see how the thickness of the border expanded. All right. You can do any of the others, all those 5 features I mentioned above. You can change that. So you can do the fill color equals green. Now, see when I hover over it, it's a different fill color. You certainly can play around with that. I'll give you another minute to tweak it around, but it's pretty much the same. You can, that's actually the fill opacity is a more interesting one. So let's say now if I hover over it, I'm going to make it a solid color. Okay. So you know, again, this is how you style the hovering behavior. And changing the hover behavior is good because it kind of gives the user a cue as to, you know, what they're on. Okay. In my final version, I actually modified it a bunch of stuff, but you can do that. Now we're going to start, you know, interacting with the data more. The one thing you notice that's absent here is that when I hover over, it'd be kind of nice to kind of identify the feature that I'm hovering over. So right now there's no tooltip. So that's what the next section is, section. Take a little, okay, so I'm just checking for questions. Okay, since no one has any questions, I'll move on. So tooltips is not something you actually attribute to the, it actually has nothing to do with the GeoJSON layer. The way you add a tooltip is by creating a column in your data frame called tooltip. So, so here's where we do a little bit of pandas. I'm copying over my states data frame here, just so that in future exercises, I'm not going to start adding a bunch of extra columns. So that way, if I ever go back to my states table, it's still pristine. So the first tip is just simply to, I'm going to call it this, I'm going to create a new column, and I'm just going to assign it to the name of the state. Okay, so that's all I've done. Now I'm reverting back to my original colors and lack of interaction. And now you can see that if I mouse over, I get the state. Now, this is not mutually exclusive with the hover style. I could also have the hover style and do this at the same time. Should point out that this tooltip, even though it is in your data, it's HTML. So if I wanted to do something a little more elaborate, put a break in, and then I want to say the FIPS code for that state is, and then add states, and I think it was called state FP. Now when I do this, now I can represent the data. So if you have a more elaborate set of data, you can pass it to a Python function. It'll format it all nicely for you and do all the things you need. Okay. And as you see, that I left you that example at the end, just as a reminder that this takes HTML formatting, and you could do, you could color the text, whatever. All right. Okay, so next here, okay, so this is now the same map as before. And we're probably going to start with this quite a lot just as a starting point. But the only difference here, I've wrapped this whole thing inside a div, which is just an HTML container. And I've added a button here. It's labeled click me. Now, right now, it doesn't do anything. I click on it, nothing. But I'm going to start to build it up. And so we'll do app callback. And for the syntax, I believe, is outputs first. So output, the output is, I want to affect the GeoJSON layer. So the layer is called border. That's the border. So that's the ID of my Dash component. So this works with any Dash component altogether. In this case, it's specifically a GeoJSON. And the property I want to actually change on this callback is the data. And as my input, I want the ID is button BTN. And this is, I probably should have named it something else just to avoid confusion. This is just this name here. And the property for buttons, again, I'd mentioned this, I think before, it's a very generic, a lot of Dash objects have this nClicks property. nClick or nClicks, I think it's nClicks. Okay, so now this is a decorator. So what I want is, I believe I call it California, because what this is going to do is it's going to filter California. Now my first input is, actually I'm going to do it this way, nClicks. And I'm going to copy the body of this because it's a little bit much. All right. And nClicks. All right. So what this does is that one of the consequences of Dash is it actually will call all callbacks initially unless you suppress it. And that gets into more detail than I really want to go into here. So basically, it may come back that nClicks is actually none on the first try. And so this is just to avoid type errors. So basically, what this is going to do is it's just based on whether it's an odd or even number click, it's going to go between filtering on my data to the FIPS code of 06, which is California, or it's going to show me the full US map here. So I run this, and if I do click me now, it shows California or not. All right. I think the next exercise, okay, yeah. So this is just, this is one example, like for instance, you may want to filter your data. Later on, you may do things as well as have data points within the city, and you're going to want to apply a filter. And in sort of that example I showed you at the beginning, I had filters for community pharmacy and different kind of health centers as an example. All right. Okay, so now what I'm going to do with the zoom control, and you'll see why later when on this sort of bonus section, you can kind of see highlighted here why I'm not doing the whole US from this example. I'm going to isolate down to California here. And I've turned on something called, okay, so now this is essentially the same model as the one I gave you before. The only difference is between California now, the click now isolates down on San Diego County, which is the county I work in. And first thing is I added the click to zoom on bounds just so that if I wanted to get into the different counties, I can navigate that way. And by the way, I mean, I can actually, these maps are extremely detailed. If I zoom in all the way here, you can kind of see here the West Health Institute, which is where I'm actually sitting currently. So just a little digression here, just also to give you guys a little more chance to play around a little bit. So anyway, so what this does, I don't have zoom. Oh yeah. All right, so what this does is the same kind of exercise here. Now, it's kind of, especially from the situation I was showing you, it's kind of irritating that I couldn't find my correct zoom level. So there's actually something here called zoom to bounds. And if I set that to true, what that does is anytime the data changes, it will rezoom the map based on what data currently is in that GeoJSON layer. So right now it's California, but if I click it again, the only data in that GeoJSON layer will be the map of, oh, I need to run it, is San Diego. So we'll zoom in on San Diego. If I click it again, now it includes all of California. So now it centers around all of California's data. And this is a very helpful feature, especially if you have like a menu to drive what the user experiences or how to focus in. Okay, since we are a little bit moving at a pretty good pace here, I will go into this. There was a question about geographic integrity or the data integrity. Now, this is a problem I ran into doing this doing the visualization that you saw at the beginning, and that is the state of Alaska is somewhat problematic if you just take it out of the box. You'll notice here that Alaska, this is set at, I do have that zoom to bounds here. It's somewhat problematic because the Western Aleutian Islands actually crosses that 180-degree longitude line. So you'll see that there's a part of it on the right because this map wraps. This is where, on the right is where 179 is, and on the left is where minus 179 is. And you don't want that, that's really not a desired effect. And because it's doing a zoom to bounds, it's trying to get everything into one frame. So that's why Alaska is not what centered as you would expect. This click me button just is to illustrate toggling between the counties. This is a random county. I think it's Denali County. And so it's zoomed properly, but the 016, which is the West, Aleutian's West, I think it is, county, it's this one. And that's the one that's causing all the zoom issues. The way I did it was I went to the shapefile and I basically called these things minus 181, et cetera. Now, if I were to take out that county, which is what this commented line is, now when I, now when I view Alaska, this is sort of the effect you would have expected initially. You would have expected to see it this way, but that Western Aleutians throws this whole thing off. So I bring this up. I think the other place you might have issues is if you're talking about Siberia. It seems to cross that line as well. There might be some other things along some of these island chains could run into that problem. So if you're working with anything around essentially anything around the international date line, you do need to be careful about this wraparound effect. All right, so it's a good time to pause for a moment, see if catch your breath, play with the visualizations for a moment, and see if you have any questions. I know so far it's been light on representing data. I've basically shown you geographic regions, and that's great if you're trying to show different zones, perhaps. where your data is already geographic, but say that you want to marry your data with geography, and that's what the next section will be on. All righty, and we'll bring up the next one. All right. Well, I am monitoring the questions periodically, so especially between exercises. So if you do have questions, please feel free to post it in the chat. All right. So now we're going to actually start mixing data with these maps. Probably one of the most basic things to do. It's called a coral pleth map. It's basically, you can think of it as a geographic heat map. So the first thing I'm going to do, okay, I'm loading the state data, and this next CSV file is actually in the package I provided, but it's and I grabbed it last week, so it's not up to date. But this is from that COVID project at Johns Hopkins. So it includes so this file contains, I should actually show what that has in it. This has all the, some of the COVID related data. Now, I think most of this is cumulative over time, so this is not the daily snapshot. And this is helpful because you can see that, again, all the states, they have this FIPS code. One thing you do have to worry about in some of these files is like the FIPS codes are sometimes presented as strings and sometimes as integers. And so when you go to do your join, you have to make sure they're the same type. Otherwise, you may have an improper join. Okay, so what I'm going to do is I'm going to create this COVID data frame. And what I'm going to do is I'm going to merge my state map, which has the FIPS code identified by state FP, and merge it with this COVID data table, and where the FIPS code is represented by the column FIPS. So in essence, I mean, it includes a few other things, but what's important is I got my COVID data here, plus this geometry column. And so now I can map any of the geographic, any of the COVID data to the geographic region. Okay, so the way the coral pleth map works is basically what I'm doing is that style option we did in the last lesson. I'm going to assign a function to it based on the feature. And so this is where we start delving into JavaScript, and it's a little more complicated than just being able to supply an arrow function. At the same time, I should also mention that included with Dash Leaflet, this is not a native leaflet component. The author created a color bar component, which actually is very useful. And so I present it here. In our case, what we're going to do is we're going to chop our data up into little buckets, 0+, 10K plus, 30K, etc. And so that's how my classes are going to be defined. I'm going to label my categories this way. And I think I stole this color scale from the example in the documentation. There's some parameters here that allow you to specify the dimensions of your color bar, and you'll have you can designate the position on the map where you would like the color bar to go. Okay, so now to the JavaScript, and this is once you want to get to really cool and advanced interactions. You don't have to be really heavy into the JavaScript, but you do have to apply some of it. All right. So this is sort of the function. Now, context will give you the, I think the feature which it comes from, and context is the context of your particular layer. In our case, the GeoJSON, and props are the properties. So you'll be able to access a property called hideout. I'm not sure why you called it hideout, but you will see here, let me go to the code and you'll see that where it's specified. You'll see that there's this property I specified for the GeoJSON layer called hideout. What this is a generic JavaScript object or Python dictionary, whichever way you want to call it, that is accessible from the context, but really serves no purpose. It's a way for you to pass something to the JavaScript. And so what, in this example, we're going to pass the color scale, and that's that color scale variable I gave you, the classes, the reason, and then the style. So I have an initial style for my map, but it's going to get modified by this JavaScript program. And then in this case, I'm just going to, this will allow me to change the metric I want to actually base it on. So that's what this color prop is. And again, this is highly lifted from the documentation. I varied it from the one that's in there a little bit. Okay, so now backing up, this is a JavaScript program. What I basically did in this first line is I'm unpacking all the properties I shoved in to the hideout. Then I'm going to take my value from the color prop, in this case, the confirmed cases property of my feature. So the feature is the row that got selected. So it's not just the geometry, but it's all the other data in that row. So I can use any of these columns in there. Let's see. All right, and then all I'm doing is all this does is I'm trying to determine which fill color I'm using based on where the value lies. So if it's between 10,000 and 30,000, I'm going to use, I think, the second color, etc. That's all that does. Now, this is using the assign feature, and that's a way of inlining it. I personally don't like that because mixing languages in code makes it hard to read, and plus your IDE doesn't really play nice with that, generally speaking. It just, as far as Python is concerned, it's a string, so I can't spot syntax errors and stuff like that very easily. You'll see that in the package here, there's an assets directory. And again, this is something I forgot to mention, but in Dash, any JavaScript or CSS in the assets directory gets automatically loaded. So I created this one called the Coralpleth demo. And so this is the same file. Now I've included the text here in the notebook, so it's a little easier to discuss. So basically what follows this window dot is the namespace, and then the first key here is the sub namespace, and that's all is the sub namespace, and then style handler is the name of the function. So the way I reference this is namespace Coralpleth demo COVID, which is my namespace and sub namespace, and then the function itself. So that's the handle. Now, both of these blocks of code will work. It just depends on your preference. For the remainder of the exercises, I'll probably use the inline just because it's easier to demonstrate, but I think in production, I would generally prefer the namespace method. All right. So with all that said and done, okay, so let's see, is there anything else I need to mention about the code? So really the only things I've added is hideout, and instead of style being mapped to that dictionary, it's mapped to this function. So that, Yeah, so I think I mentioned it, but I'll reiterate it. So what I do is the only style feature I'm changing based on the value is the fill color. And so now when I graph this, I have this kind of map. And so, and not surprisingly, the most populous states have the most case rates, most confirmed cases since the beginning of the pandemic. This, you know, so this is sort of how you would start out with, you know, first one way of representing some of your data in a geographic form. Okay, so let's see. Anyone have any questions at this point? I think we're doing pretty good on time here. Okay, so this is probably the extent. This is the extent of what I'm going to talk about as far as sort of these boundary type of data points. The remainder of this is actually going to talk about you know, point data or scatter plots. All right, so I am going to go to my next lesson. All right, so this is going to be the basic portions with point data. Okay, so for this one, I'm going to read that US cities. And the comment here is, I believe that was sort of in their terms of use, which is that you just simply have to state the origin of the data. Again, this all goes back to attributions. All right, so just to kind of go back to what we did with the boundaries, if you do point data, you can also do the same trick with the tooltip. The tooltip is the name of the, if there's a column in your data called tooltips, it's going to create a tooltip from that. If there is no tooltip column, it will not. So I'm going to go ahead and do that. And in addition, since if I did all the cities in this map, it's going to be a mess. I'm going to isolate one city. And the reason for picking New Jersey is after playing with this with a lot of different states, it actually has the widest diversity of population density cities, if that makes any sense. In other words, when I start coloring by population density, it has the most colors. It turns out that most cities have roughly a fairly consistent density. So my maps initially started out looking actually quite monochrome. Okay, let's see. All right, so we'll start with the basic scatter plot. Now there's this property called point to layer, and I'm only assigning it to none at this point, just because I wanted to remember to include it, to be quite honest. But I'm setting it to none just so that you know what it looks like when you don't actually specify any customization. All right, so when I do that, with all the cities that's in this database for New Jersey, it looks like a mess. All right, now it's less so when I start zooming in, you can kind of see where the cities are. And I believe this is a city, I forget what the population cutoff is, but this file is populations over maybe 25,000. But you can see that my tooltips work. I hover over, and these things are called markers. The markers are pinned at the location of the city. So, it's that tip, and you can specify in your marker where it's centered, so your hot spot. Okay, so this is not, for this kind of graph, if you don't have a lot of points, this is fine. But if you want to get into really when you're plotting a lot of points on a map, this obviously just looks cluttered and it's, pretty much not useful. You'd actually rather have a point. Okay, so, and I'm going to just copy the code here from here, but so point to layer, what that is a JavaScript function telling it at a given point plot what to show. All right, so I'll go over this. There's a little bit of what is it? A little, well, actually, this one's okay, and there isn't. Later on, there will be some that are creating the icons out of CSS. There is a circle marker that's provided as part of Leaflet. Now, this L dot, I'm sorry, is indicates it's out of that Leaflet library. You can look up in that Leaflet documentation the specific options for the circle marker, but basically here we're saying we want the fill opacity to be 1. It's not going to be stroked, which means no border or outline on it, and the radius will be 5. Now, if I do that, instead of these kind of pins, I'll get a circle. And so this is what it looks like. So this is a little bit better, but still, you may want to do a little bit more than this. Okay, because it's still just, it's a bunch of blue dots and, we're not conveying any data actually. I'm just showing you where there's city locations. So the next thing I'm going to do is, okay, I think from here, also from here on in, much more of this is going to be canned in the notebook just because it's just too much to type by hand and kind of demonstrating it to you. So, so it's going to follow more of the format now that I'm going to show you the code and try to explain it and then run it, as opposed to I'll modify it on the fly. Now you can still feel free to muck around with this and tweak it. Okay, so I should point out this Chroma library is actually it's a JavaScript library that's used for color scale. So you can kind of seamlessly go from one color to another. So in this case, we're going from red, yellow, green, blue to purple, which is rainbow colors. But what the Chroma scale will do is if I pick a point that's between red and yellow, it'll find the appropriate shade that'll make it look right. Okay, and then we're going to create a color bar. Now, this basically, you specify the color scale and your dimensions. Okay, but of course, the meat of everything is this JavaScript function, point to layer. So, okay, again, we pull out our critical properties from the hideout. What this is doing is it's actually just picking the color. It's very much like the previous example. It's picking out the color based on the color property. So instead of doing the discrete bins that we did last time, this is actually trying to do a sliding scale of color. Okay, and then the only difference now is when I create my circle marker, I'm specifying this specific fill color, unlike what I did in the previous example where the fill color was not specified. So, and I believe the rest of the code runs the same. The reason why I made a separate copy is that I wanted to add the color bar here. So now, again, most of the density is actually, most of the cities aren't that dense, but you can kind of see near New York, of course, it's starting to get a little red. Now here we're actually expressing some data via visualization. At a glance, you can tell where population is denser in the cities, and I can go in and look at it. And it's actually only a few cities. I believe one of these cities, actually, I think I looked it up, has the highest population density in the US. I was actually kind of surprised by that. I thought it would be like Manhattan or something, but all right. So this kind of concludes the way what I have on just plotting data by points right off, but let me see. Anybody have any questions or want a little time to tweak this? All right. We'll go to our final lesson, and this is actually probably the singular thing that caused us to go with Dash Leaflet when we were trying to do our visualization, and that is its ability to do clusters. Now, clustering is not part of Dash Leaflet. It actually is from a open source library produced by Mapbox, actually called Supercluster. And some of the advantages here is it does the clustering on the client side so that your server isn't busy running clustering every time someone clicks on something. So that's all done on the client side, which also makes the clustering operation run much smoother and faster. Okay, so to start off with, I've got the same example as last time. Oh, I do want to mention, before I go too far, I don't remember if I did it in the previous lesson, but I did convert, without telling you guys, the data to GeoBuff, which is done with this helper function applied supplied in this module Dash Leaflet Express. It's just a few, that it just contains a few helper functions. It also contains one of the convenient helper for creating a discrete color bar. And you may have noticed that. I kind of glossed over that as well. So this was our previous. Okay, so this is all the setup that we used to our previous point or scatter plot, basically. And this is what it looked like where we left off. Now, you may notice I snuck in a couple parameters here. And let's go over the part. First of all, there's this property called cluster. So if I make that true, now this is what happens. Whenever points are close together, it puts up a cluster instead. So these red dots aren't really close enough to the threshold of the other cities so that they stand out. But inside each of these, like this one with the 4, that shows that there are 4 there are 4 cities within that cluster. Now, as I zoom in, they break up, and it's based on a proximity at the level you're at. So it's a very good way to kind of, when you have regions of high density points, you can capture it with a single marker. And then when it's lower density, you can actually have the individual points. A few of the properties that go with that, there's this thing called supercluster options, which is actually how you specify some of this. Now, radius is the thing that dictates how how close I cluster. So if I change this from 40 to 100, much fewer clusters because it's covering a wider region with the cluster. Max zoom is, or let's see, I think it's min zoom is the normally comes in, we start out at zoom level 4, or this is zoom level 7. So if I go, I think it's 8, that tells you beyond that zoom level, it will no longer cluster. Did I have it the other way around? It might be max zoom. Apologize, it's not something I actually use, but yeah, you see at that level, when I reached, so I'm start out at 7, and at 8 it will still, let's see, this is 7. At 8, it still clusters, but at 9, it exceeds the max zoom, and now it will not cluster. So that's something allows you to control the zoom. The other thing is min points is sometimes useful. Let you cluster, let's say 5. That means that all clusters have to have at least 5 points in them. So if I start zooming in, it'll start breaking them up sooner because no cluster will have a number smaller than 5. Okay. Let's see. One other thing. Oh yeah, I did not mention this. I did also sneak in the zoom to bounds on click. If you actually have that turned on, the behavior is if you actually click on the cluster itself, it will zoom in to the zoom level that would, it's kind of hard to explain it. It basically zooms in deep enough so that that cluster breaks. So not necessarily all the way down to nothing, but so like the 61, it'll zoom in until that 61 becomes a bunch of other clusters and so forth. And that's actually a convenient behavior as well. All right. Okay, so you can kind of play around with the clustering, and the next example is basically I just wanted to, so far we've dealt so much with the interactions that are built into Dash Leaflet and not talk so much about the interaction with, say, other parts of your visualization. I just want to kind of remind everyone that every property, including this true or most properties, I shouldn't say every, are addressable via the callback. So, for example, here, what I've done here is on that layer, I've made the cluster property adjustable, and it basically toggles between true and false. So now when I do the click me button, it goes between the two. And I believe it'll actually preserve the zoom level. And you can do that with anything. You can change, you can change the different options. You can change the zoom resolution. I guess the one thing, and I don't have any material for this, but that I hadn't mentioned is that we don't have any examples of using the, clicking on the feature causing a reaction somewhere else. Okay, so the final topic here that I have prepared anyway is customization of that cluster layer. You may want to change the appearance. So this is sort of a scale of how I would have taught it, but there's just so much to type. So the first version of this, cluster to layer, what this does is it puts a custom icon. Now this icon is created using CSS and HTML styling, and it kind of, you probably don't really need to know much about this beyond the fact of, of being able to copy this from somewhere. But if you are gifted in that, in all kinds of the CSS stylings, you can make arrows and stuff like that. You can use this kind of template. The other thing you can also do is you can actually, these markers can also be URLs to particular graphics. So I've seen different types of pins, for instance, based on your application. There are examples of that in the documentation. So if we run this one with the cluster to layer version 1, oh yeah, I guess I should back up a bit. Cluster to layer is like the point layer function, pretty much analogous. So if you supply that function, that property, now you get this nice circle with the number inside. And as you can see in my example here, the color on the circle is black, and we made the size 40 by 40. You can play around with that if you want. The second iteration here was now I'm scaling this based on the average density. So it matches sort of that color scale we have. I won't go into too much detail. Most of this is pretty straightforward. But there's one thing from this index variable that the function does get passed. You can run this thing called get leaves, which will retrieve all the features within that cluster. So if you have 10 points in there, you can get access to the 10 points. And in this case, we get the 10 points, and we want to extract the the population density from that, and then average them out. Actually, now that I think about it, this is probably not the right kind of way to do the average, because you should weight it based on population too. But that's kind of another matter. So anyway, the results of this. We did layer number 2. Uh-oh, what happened now? Oh, I didn't run it. We do layer number 2. Now the circles tend to match the color bar to some extent. So if I go in a little bit closer, and remember our hotspot was over here near New York, you can kind of see now the average density is getting a little higher. Okay, the final enhancement is that you notice that while going over the points themselves have that tooltip, there's no tooltip based on the cluster. So the cluster gets passed this thing called feature. Now, the cluster itself is a feature, and it's not related to anything from your data specifically, except the leaves make up this feature. So, but it works exactly the same way. You just assign the property, and it's really just this one line. You're adding another column to the feature, and you're calling it tooltip. So that's the same theme throughout the whole thing for doing the tooltip. In this case, I'm going to put the number of points in that cluster under number, and then the mean value over here. So if I do that, now I hover over. Oh, did I not? Oh, I didn't change the, sorry, I did not change the cluster to layer function. Now you see I have a tooltip, and so that's all the prepared material I have. I can take questions if you want. We have about 10 minutes left.
Yeah, so Dr. Lu, I was wondering, how have you found any work where we can do the analysis of how much time it will take for that, depending upon data? Like if we want to plot large geographical area, how much time it will take, and like how fast it is, something like that?
Not really any analysis. As I said, we needed to have 70,000 data points loaded in what felt reasonable to the person. And by comparison, when we tried like taking a notebook and deploying Voila, for instance, it took 15 minutes, and that's, it had to be on the order of seconds. And so you may, if you have a very large data set or a lot of geographic regions, you may have to play some tricks to push out only the data that's necessary. One of the things I did not do here is I did not drop any columns for data that I wasn't representing. When you want to go into production and really streamline it, you only want in your GeoJSON to contain only the columns that you're going to be manipulating. Just thinking, the only other thing I guess I did not show was, I don't know if I could base it off of an example here. But you can, one of the really useful things, let me see if I can quickly change this example. I do go counties. and change this to click. So this might be a way that you might, let's see, let's just call this thing, I'm not going to rename too much. Do something, because I feel like after going through this again, one of the things I'm probably missing out on a little bit is how you would use the map to drive other parts of your visualization, like maybe a graph on the side. So let me just see. If I do this, I won't rename anything. Let's just do, so the input will be, actually, let me do this first. This might throw a trace back for them. So I don't remember how it comes exactly. So if I click, say, a county, I'm not sure I got this done right. Well, anyway, this is sort of what would happen. And let's, I'm just going to, I probably can't get the code to work right now, but you might do something like input, well, in this case, I would say return, might do something like the input and forget one of the fields, name maybe. So what this would do is when I click on the county, it would then set the text to the name of the, see, then the specific row gets passed back to me. And then I don't remember if name was actually in the row, but then you could actually use that and say, filter a graph on the right. Instead of, right now it's just very simple. I was hoping to be able to just print the name of the county below here, but oh, maybe it would, maybe it does work. Let's see if that even works. I didn't even see that it done anything. That probably traced back. Yeah, it's not return none. Anyway, yeah. So that's, I think that's part of, I've seen examples like using other tools like Tableau where you might actually have a graph on one side and data on map on one side and graph on the other, and you want the map to drive the graph and the graph to drive the map. And you can do that here. It's just a matter of using these inputs and outputs.
So there is one question from Alex.
Okay, how's the output of this work used on production in your case? Okay, so the way we've done this, in this case, we're actually using AWS serverless to deploy. You can, at the heart of this is just a Flask server, so you can spin it up on your own server. You can, I've done it in ECS containers, which are basically Docker containers on AWS. But the specific graphic I showed you at the beginning was using serverless, which employed AWS Lambdas. One downside to that was that it does have a cold start if it hasn't been run for a while, and that always bugged me a little bit. That's why if you actually go to the site, it's a little bit slow coming up, and we threw in an initial spinner graphic just so that the user doesn't think nothing's working. If you want a highly interactive, highly responsive deployment, I would do something that, I'd try to mitigate the startup time. It is, in answer to that last question, it is actually a Flask application. If you actually look at Dash, it sits on top of Flask, and you can actually access the Flask server underneath Dash if you wanted to. If you needed to do things like apply authentication, for instance, you could still use Flask login and then throw Dash on top of that. So So all of this is actually Flask. If you really look at the workings, it pushes out a Dash Leaflet library, and not Dash Leaflet, a Leaflet.js library, and controls it from there, and it just does all of that for you. But you could deploy by a Flask server that throws up a Leaflet.js and a bunch of your own JavaScript and do the same thing. It's just obviously from if you're a web application programmer, then that would be what you might do. But coming from the side of being a data scientist, you kind of want as much of that handled for you as possible.
So I think we are closing to our time. So if we don't have any further question, yeah, I think one question pop up. Yeah, can the visualize is the top of some live dynamic data source making data getting changes?
Yeah. Yeah, I mean, as long as you have the appropriate trigger in the Dash side, yeah, that's entirely possible. I mean, from within the framework, you saw on one of my examples of filtering, the original example of filtering where I chose California and not California with the data, that's all within the data that had loaded, but you could dynamically change that data and any kind of change trigger. There are callbacks so that you can push to the output, like JSON, the GeoJSON output layer. As long as you set that, any callback can trigger that. So yes, you can make this a real-time updating. Now, there are some tricks with the plumbing of all that. I don't pretend to know how your data is your updated data is actually getting into the server, but it can be done that way. I should bring up, I guess the last slide was just, if you do have other questions, you think of something later,
yeah,
I'd go to the GitHub. Probably the best way is to post an issue on the GitHub repo that's in your materials on that questions notebook. And the reason for doing that is that way, others can see the question and might answer their questions. And also, I believe PyData Global has, I'll be on the Slack channel for a while, so you can ask me questions there too if you want. I don't remember, I thought they said there was supposed to be one specifically for the workshop, but if there isn't, just at me on the Slack channel. I'll try to get to you. Definitely for the next couple hours anyway.
Yeah. Okay, so I think we are now about to close our time. So yeah, I will take opportunity to thank Dr. Lu for your interacting and this very important topic on my visualization. Nowadays, lots of my visualization techniques are coming and requirements are also coming. So thank you. I hope everyone have enjoyed. So thank you. Have a nice day.
All right. Well, thank you all for coming.